Good day everyone, today we will tackle about the life and works of Tycho Brahe and Johannes Kepler. Tycho Brahe. Tycho Atkinson Brahe was born into highly aristocratic, very wealthy family on December 14, 1546. He was born in his parents' large manor house at Kernstock in the Danish region of Scania, now Sweden. His father is Otto Brahe, a member of a royal court, and his mother is Great Bill, an important aristocrat. Ang aristocrat po is mayamang pamilya or may mataas na katungkulan. Sina Brahe po is 12 silang magkakapatid at siya po ay ikalawa sa 12 magkakapatid. Tycho Brahe was kidnapped by his uncle and his aunt, Georgian Brahe and Inger Oaks, when he was 2 years old. Nakidnap po siya ng kanyang mga tito at tita noong ang kanyang mga magulang ay nasa malayong lugar. And naniniwala yung mag-asawa na kumidnap sa kanya na sila is, kumbaga capable sila na magpalaki ng bata at meron silang ipapamana. And kinalaunan ay pumayag din yung kanyang mga magulang na ipaampon si Tycho sa mag-asawang si Georgian Brahe at saka si Inger Oaks. Astronomy began on August 21, 1560 noong nakita niya yung solar eclipse sa Copenhagen, na yung solar eclipse na yun is sobrang kitang-kita yung solar eclipse dahil almost half of the sun was covered. And hindi dahil sa nakita niya na maganda yung nag-push sa kanya to push astronomy. Ang nag-push sa kanya is naging interest siya dahil na-predict ng mga astronomers kung kailan mangyayari yung solar eclipse, and kumbaga na-inspired siya and nagustuhan niya na gumawa ng mga predictions ng katulad na. Family was powerful and militaristic family. By tradition, their male children became a warriors serving the interests of the family, the king, and the Danish nobility. Yung family po ni Tycho is very powerful family sila and militaristic. Yung mga anak nila lalaki is dapat ay maging warriors, kailangan nakikipaglaban and serving the interests of the family, the king, and the Danish nobility. However, her foster mother Inger came from the academic family, and she persuades to her husband Georgian Brahe na Tycho Brahe should receive an academic education. Kailangan daw po si Tycho is makapag-aral at makapagtapos. Summer of 1565, Tycho's foster father Georgian Brahe was in the process of making Tycho a legal heir, and Georgian was appointed as vice admiral of the Danish fleet and died because of pneumonia in the summer of 1565. Noong summer po ng 1565, yung stepfather ni Tycho na si Georgian Brahe ay nasa proseso na gawin si Tycho na naging isang legal na tagapagmana niya. Ngunit si Georgian Brahe po ay namatay dulot ng sakit ng pneumonia noong summer na 1565, kaya hindi natuloy yung paggawa kay Tycho na maging isang legal na tagapagmana niya. In April 1566, Tycho Brahe back in Germany, and he got an argument with other Danish students who like him. The cause of the argument is not known. Sometimes they claim that they are arguing who is the best mathematician, but this is probably a myth. Two students fought a duel with swords, which resulted Tycho losing a front of his nose. Then later he returned to Denmark and began experimenting with metal fittings. And after the experiment, he wore a skin-colored metal prosthetics for the rest of his life. Yung metal prosthetics, yun yung nag-serve na parang kapalit nung ilong niya na nasira. I received a news that his father, Otto Brahe, is ailing. He came back to Denmark. His father died on May 1571, leaving a 20-year-old Tycho as a substantial legacy. Astronomy without telescope. Galileo Galilei studied the heavens with a telescope for the first time in 1609. Sadly, Tycho did not live enough to see this. All of his observation is only based on his naked eye using the finest astronomical instrument in Europe. Tycho built on his own observatory island, and he named the island Oranaburg Arena after the muse of astronomy.
Tycho's system. The Tychonic system or Tychonian is a model of the universe published by Tycho Brahe in 1588, which combined what he saw as the mathematical benefits of the Copernican system or heliocentrism with the philosophical and physical benefits of Ptolemaic system or geocentrism. Tycho tried to produce a model consistent with the best of both Ptolemaic and Copernican. Copernican heliocentrism is the astronomical model developed by Nicolaus Copernicus and published in 1543. This model positioned the Sun as the center of the universe, motionless, with Earth and other planets orbiting around it in circular paths modified by epicycle and uniform speed. Copernican model displays the geocentric model of Ptolemy that had prevailed for centuries, which had placed Earth at the center of the universe. At tama nga si Copernicus, ang 5 planets na kinabibilangan ng Mercury, Venus, Mars, Jupiter, and Saturn are to orbit the Sun. Copernicus believes the Sun is at rest near the center of the universe and that Earth is spinning on its axis once. Daily revolves annually around the Sun. This is called the heliocentric or sun-centered system. Itong Brahe system is a mathematical model of the universe formulated by the Alexandrian astronomer and mathematician Claudius Ptolemy. The Brahe system is geocentric cosmology that starts by assuming that the Earth is stationary at the center of the universe. The natural expectation for ancient societies was the heavenly bodies, sun, moon, planets, and stars, most travel into uniform motion along the most perfect path possible, a circle. Ptolemy believes that the heavenly bodies' circular motion were caused by their attached to unseen revolving solid spheres. He discovered that if he represented the motion of the sun, the moon, and the 5 known planets with spheres. However, the paths of the moon, the sun, and the planets are as observed from the Earth are not circular. Ptolemy had said that the tectonic system, Earth is at the center of the universe, the moon, the sun, and the stars orbit the Earth, and the 5 planets orbit the sun. 1575, Brahe built an enormous observatory in an island offered to him by King Frederick II. Danish King Frederick II granted Tycho the island of Venus of Copenhagen by royal decree and annual stipend to further his astronomical research. Tycho used his independence and financial security to establish the Uraniborg Observatory on the island. Si Brahe ay may lubhang limitado sa kanyang pananaw sa universe at umaasa ang kanyang obserbasyon on what he could see with the naked eye. In Tycho's model and solar system, the idea of geocentrism and heliocentrism were combined.
Good day everyone, I'm Tommy from BCAED1. Today we're going to talk about Kepler's law of planetary motion. Kepler's law of planetary motion are laws describing the motion of the planet in the solar system, derived from the German astronomer Johannes Kepler. Johannes Kepler, born in Wilderstadt, Württemberg, in the Holy Roman Empire. He is a German astronomer and mathematician who made significant contribution to understanding planetary motions. He was sickly child and his parents were poor. Despite of being poor and sickly childhood, his intelligence earned him a scholarship to study theology. In 1596, he published Mysterium Cosmographicum, defending his model of the solar system. Later, Kepler worked with Tycho Brahe in Prague, focusing on Mars orbit using Brahe's data. He formulated his 3 laws of planetary motion, which accurately describe planetary orbits and remain foundational in astronomy today. There are 3 laws of planetary motion, and let's talk about it one by one. Kepler's first law on planetary motion is sometimes referred as the law of ellipses. It can state that all planets move around the Sun in elliptical orbits. Having the Sun as one of the foci is a plural form of focus. This means that planets are orbiting the Sun in a path described as an ellipse. This is a feature of ellipse. Suppose this ellipse where the planet Earth moves. The Earth moves around the Sun is located either one of the foci of the ellipses. Now let's move on to the second law. Kepler's second law of planetary motion, sometimes referred as the law of equal areas, it can be stated as radius vector joining the planet to the Sun without equal areas in equal length of time. The second law describes the speed in which any planets will move while orbiting the Sun. Now, while the planet close to the Sun, it moves fast, but when a planet is far from the Sun, it moves slowly. So, if we draw an imaginary line on the movement of the planet and the Sun, we can see that when the planet is close to the Sun, it will form a wide short triangle, and it's called perihelion. And when a planet is far from the Sun, it will form thin long triangle called aphelion. But Kepler failed to explain why planets maintain their respective orbit. That issue was addressed by Newton. Rotation of the Earth. The spinning of the Earth around its axis is called rotation. The axis has angle of 23.5 degrees and is perpendicular to the plane of Earth's orbit, which means Earth is tilted on its axis. And because of this tilt, the northern and southern hemisphere lean in direction away from the sun. The rotation of the Earth divides into a lit-up half and a dark half, which give rise to day and night. Revolution of the Earth. The movement of the Earth around the Sun is a fixed path is called revolution. The Earth revolves from west to east. The Earth completes one revolution around the Sun is 1 year or precisely and 365.242 days. The revolution speed of the Earth is 30 kilometers per second.
Now let's begin on Kepler's third planetary motion, which is the law of harmonies. Law of harmonies can be stated as the square of the sidereal period of the planets that are directly proportional to the cubes of their mean distance from the Sun.
It compares the orbital period and radius of orbit of the planet to those of other planets. It is the ratio of the square of the period to the cubes of their average distance from the Sun. It's the same on every planet. The comparison of each planet shown in this illustration. So what is the meaning of this? Kepler's third law of planetary motion means how long a planet takes to go around the Sun, which is its period. It's related to the planet mean distance from the Sun. That is the square of the period divided by the cube of the mean distance is equal to constant. And for every planet, no matter what its period or distance, t squared all over r cubed is the same number. At ngayon ay tuturuan ko na kayo kung paano nakuha ang period or yung time, average distance at yung ratio. Kapag ang hinahanap natin is time, ito ang formula nun. T squared is equal to constant multiplied by r cubed. So yung k or yung constant, ang representation nun is yung 1 year squared all over AU or autonomical unit cube. Tapos yung R naman is yung average distance. So, ang magiging formula natin is T is equal to square root of 1 year squared all over autonomical unit cube multiplied by R cube. So, para matanggal yung 2, dun sa T ay square root natin yung both side ng equal. Kaya nag-come up tayo sa formula na T is equal to square root of 1 year squared all over AU cube multiplied by R cube. So, dito na tayo sa Mercury. So, ang hinahanap dito is time. So, gagamitin natin yung formula. T is equal to 1 year squared all over AU cube multiplied by R cube. So, papalitan lang natin yung R which is yung given na average distance which is yung 0.39 AU. And then, after nun is i-cube na natin yung 0.39 AU. So, ang kalalabasan nun is 0.0593 AU cube. So, kung mapapansin niyo merong AU cube dun sa constant. So, at dahil meron AU cube din yung kinube natin, ika-cancel out natin yun parehas pati yung nandun sa constant. So, 1 year squared multiplied by 0.0593 is, ang kalalabasan nun is 0.0593 year squared. Then after that ay square root lang natin yung 0.0593 year squared. At ang kalalabasan nun ay 0.243 years. So ang time sa Mercury ay 0.243 years. So dito naman tayo sa paghahanap ng ratio. So ang formula ng ratio is t squared all over r cubed. So dahil alam na natin yung formula ng ratio ay kunin na natin yung ratio ng Mercury. So sulat lang natin yung formula which is yung t squared all over r cubed. So after nun is palitan na natin yung formula which is yung una ay yung time which is yung t squared. So ang lagay na natin yung 0.243 years and then yung nasa baba naman which is yung average distance is 0.39 AU. So lagyan natin ng cube tsaka ng squared. So after ma-squared nung time at ma-cube nung ratio, i-divide natin to at makukuha natin yung 0.995 years squared all over AU cube. So yun yung ratio ng Mercury. For another example ng paghahanap ng time is yung sa Jupiter. So, sulat lang ulit natin yung formula. Then after nating masulat yung formula is palitan na natin yung average distance which is 5.20 AU. So, i-cube ulit natin yun. So, kapag na-cube na natin yung 5.20 AU, ang kalalabasan nun is 140.600 AU. So, dahil merong AU cube dun sa average distance at meron din dun sa constant, ay ika-cancel out na natin yun. Tapos, ita-times natin yung average distance, yung na-cube na average distance doon sa 1 year squared. Tapos, is-squared na natin yung 140.608 year. So, ang kalalabasan nun is 11.8 years. So, yun yung time sa Jupiter. At dahil nakuha na natin yung time sa Jupiter, ngayon naman ay hanapin naman natin yung ratio nun. So, sulat lang ulit natin yung formula, then palitan na natin. So, ang time sa Jupiter is 11.8 year at ang kanya namang average distance is 5.20 AU. So, squared muna natin yung 11.8 year. So, ang squared nun is 139.24 years squared. Tapos, yung cube naman ng 5.20 AU ay 140.608 AU. So, kapag dinivide na yun, ang kalalabasan nun is 0.99 years squared all over AU cube. So, yun yung ratio sa Jupiter.
Ngayon naman, dahil alam na natin kung paano kunin ang time, ngayon naman ay tuturuan ko kayo kung paano kunin naman yung average distance. So, ang formula ng pagkuha ng average distance is r cube is equal to au cube all over 1 year squared multiplied by t squared.
So kung mapapansin ninyo, yung r ay may cube. So ang gagawin naman natin yun is cube root natin yung both side ng equal.
So ngayon, kukunin naman natin yung average distance ng Venus. So, isulat na natin yung formula. So, ang formula is r is equal to cube root of au cube all over 1 year squared multiplied by d time. So, papalitan na natin yung time which is 0.615 squared. Yun yung time sa Venus or yung years. And then, after nun is square root natin yung 0.615. So, kapag na-square root na yung 0.615, ang kalalabasan nun is 0.378. Kung mapapansin niyo yung year squared, meron din sa constant. So, ika-cancel out na natin yung year squared. So, ang mangyayari, ang kalalabasan nun is cube root of 0.378 au cube. So, kapag kinube root na natin yung 0.378,
Ang kalalabasan ay 0.72 au. So yun yung distance ng Venus from the Sun.
so sa pagkuha naman ng ratio ay same lang din yun. So, sulat natin yung formula which is t squared all over r cube. So, palitan na natin yung t squared at yung r cube. So, ang time sa Venus ay 0.615 year. Tapos sa average distance naman ay 0.72 au.
So kapag na-square na natin yung time at pag na-cube na natin yung average distance ay i-divide na natin yun at ang makukuha natin is 1.01 year squared all over au cube. So another sample ng pagkuha ng average distance, gamitin natin yung sa Mars. So copy lang ulit ng formula, then palitan na natin yung time or yung t ng 1.88 years, tapos i-squared natin yun. Tapos pag na-squared na natin, ang kalalabasan nun is 3.5344 year squared. So cancel out natin yung year squared doon sa constant tsaka doon sa ini-squared natin. So after natin ma-multiply, ang kalalabasan nun is cube root of 3.5344 au cube. And after natin ma-cube root yun, ang kalalabasan nun is 1.52 au. So yun yung average distance ng Mars from the Sun. Ngayon naman ay kunin natin yung ratio. So sulat lang natin yung formula, then palitan na natin. So yung time ay 1.88 year at ang average distance naman is 1.52 au. So ang square root ng 1.88 ay 3.534 at ang cube naman ng 1.52 ay 3.51. So after natin ma-divide, makukuha natin yung 1.00 year squared over au.